Hello everyone, welcome back to my YouTube channel. Lately we discussed the article Electric Field Intensity on an Axial Line of a Dipole, but now we are going to talk about the electric field intensity on an equatorial line of a dipole. In order to understand this article well, we first of all need to talk about the diagram in detail. So, first of all, we need to consider a dipole, and we know a dipole is a pair of equal and opposite charges. That is why we are going to consider two equal and opposite charges which are separated by a certain distance, and this distance is a very small distance and is represented by 2a. This is called a length of the dipole. As we want to talk about the electric field intensity on an equatorial line, that is why we need to understand what equatorial line is. So any line which is perpendicular to the length of the dipole, but most importantly passing through the center of the dipole, is called an equatorial line. So this O point is representing a center of the dipole. Therefore, O is dividing this length of the dipole into two equal halves, that is length A from O to A and length A from O to B. So this length is marked as length A from O to B. Now this dipole is divided into two equal halves, and I just want to find the value of electric field intensity on an equatorial line. So I will consider this point P, which is lying on the equatorial line, such that this point P is at certain distance from A, as I need to calculate this distance from A point to P point. That is why I have just joined this line, and I also need to find the distance between P point and B point. Therefore we're gonna join this line too, but we first of all have to mark the distance of point P from point O as x. So the distance of point P from point O is taken as x. This is the perpendicular distance of point P, and point P is the point of observation where a unit positive test charge Q naught is lying. So as we have taken a unit positive test charge, unit indicates the magnitude of the test charge is 1, and we have taken a positive test charge over here, and test charge word indicates that the electric field of test charge is not interfering with the electric field of the dipole. So if we consider plus q naught charge placed over point P, that means this plus q charge which is placed at point A is going to repel the plus q naught charge, because plus q naught charge and plus q charge are of same nature. So that is why what we are going to do, we are going to extend this line, and this line is indicating us that plus q naught charge is going to experience a force of repulsion along this direction, along the direction AP direction. Therefore I will mark it as EA, that is electric field intensity at point because of charge which is placed at A point. On the other hand, at P point we already know, here we have plus q naught charge, unit positive test charge is placed at P point, and here at B point we are having a negative charge. So plus q naught charge and minus q charge are of opposite nature. That is why this minus q charge is going to attract this unit positive test charge towards itself. Therefore electric field because of B point will act in the inward direction. That is why we are going to mark electric field intensity at point P, because of charge placed at point B will be in the inward direction. Now let us suppose that this line makes an angle theta with this direction. So this line is also going to make angle theta with the horizontal direction, because A point is at the same distance from the center of the dipole as is the B point, and P point is lying at the same distance from the both points A point as well as B points. How we can say that P point is lying at the same distance as is it is lying from the A point? Because here, from here we can check this distance. The distance of point P from O is x, that is a perpendicular, and distance of point O to A is A. So we can apply Pythagoras theorem in order to find the length AP, and according to Pythagoras it will be equal to under root of x square upon plus a square. So that is why this distance is going to be under root of a square plus x square. Similarly, if we will check this distance, this is perpendicular distance x, this is base distance x, distance a, and here we are having angle 90 degrees. So in order to find the hypotenuse, we can apply Pythagoras theorem, and according to Pythagoras theorem, we will get the distance between P and B as a square plus x square. Hence these two distances are same, that is AP is equal to BP. So now we need to further explore this diagram. As I have taken this angle theta, and this line is acting in this direction, that is electric field, because of the charge placed at point A is acting along AP direction. Now I just need to resolve these two fields EA and EB into two parts. In order to do that, what I am going to do, just consider an imaginary parallel line along this direction. A line parallel to AB is lying along this direction. If this is angle theta and this is a transversal, so we are having this angle as theta angle. If two parallel lines and this is a transversal, so this angle is acting as angle theta because these are the corresponding angles. So what we are going to mark, we are just going to mark a parallel line along this direction. Here we are having angle theta, as we have seen that EA is making an angle theta with this direction. Therefore, the component of electric field which will act along this direction is EA cos theta. As we have already done this in class 11th, that we can resolve the vector into two components. So here I have resolved electric field intensity vector because of the charge placed at A into a component EA cos theta. So the perpendicular component will act along the upward direction, and it will be written as EA sin theta. Now if I talk about EB, if I focus on EB, here it is making an angle theta. Now this line is parallel to the line BA line, and BP is acting as a transversal. If here is angle theta, so this is also going to be angle theta, alternate interior angles. That is why I will say B is making angle theta with this line. So here we are having angle theta. If EB is making angle theta with this line, so the component of electric field along this line will be taken as EB cos theta. So as I have taken EB cos theta along this direction, I want to resolve into the other component EB sin theta. Perpendicular to EB cos theta is this direction because EB is acting as a resultant in the middle of these two perpendicular directions, this direction and this direction. I cannot choose EB cos theta along this direction and EB sin theta along this direction. This will be a wrong approach because resultant is lying in this direction. That is why the component EB sin theta will act along the downward direction. So in this direction, we will be having a component of electric field because of charge placed at point P as EB sin theta. So I will write it as EB sin theta. Now we have already made a well-labeled diagram which actually indicates the clear picture what we want to find. First of all, I just want to write down the values of electric field which electric fields due to charges placed at point A and B. And in order to write the value of electric field, we already know the general formula, that is E is equal to 1 upon 4 pi epsilon naught Q upon square of distance. So I will write R square. This is just a general formula. And looking at this general formula, if I want to find the magnitude of electric field intensity because of charge placed at point A is equal to 1 upon 4 pi epsilon naught Q upon, instead of writing R square, here I will write a P square because unit positive charge test charge is placed at point P. That is why I am mentioning AP square. So it is equal to 1 upon 4 pi epsilon naught Q upon under root of a square plus x square whole square. So the value is 1 upon 4 pi epsilon naught Q upon a square plus x square. So this is our equation number 1. And next thing which we want to find is electric field because of charge placed at point P. It will be written as 1 upon 4 pi epsilon naught Q upon BP square is equal to 1 upon 4 pi epsilon naught Q upon under root of a square plus x square whole square, and is written as 1 upon 4 pi epsilon naught Q upon a square plus x square. So this is equation number 2. So considering the equation number 1 and 2, we can say magnitude of EA is equal to magnitude of EB. Now what we have to say now, EA, magnitude of EA is equal to magnitude of EB. Therefore EA sine theta is equal to minus EB sine theta. Why I have taken minus sign? I have taken this minus sign because EA sine theta is acting along the upward direction while EB sine theta is acting along the downward direction. So the net effect of this is 0. This implies EA sine theta plus EB sine theta is equal to 0. Hence these components EA sine theta and EB sine theta are not going to contribute into the net effect of the electric field intensity because of the dipole on an equatorial line. Now we need to focus on the point that the component EA cos theta and EB cos theta both are acting along the same direction along the same line. That is why the net effect on the equatorial line at point P will be along this direction, and it will be because of the components EA cos theta and EB cos theta. Therefore from diagram you can directly write, therefore from diagram net effect is because of components EA cos theta and EB cos theta. Hence electric field intensity on equatorial line EE is equal to EA cos theta plus EB cos theta. And in order to solve this equation, we just need to take cos theta as common. You just write as EA plus EB cos theta, and now we can substitute the value of EA and EB. Therefore we will be having EE is equal to 1 upon 4 pi epsilon naught Q upon a square plus x square plus 1 upon 4 pi epsilon naught Q upon a square plus x square, to be taken into the single bracket cos theta as a common thing. Now I want to put the value of cos theta also, but before doing that I just want to simplify this equation one more time. That is why I will write it as 1 upon 4 pi epsilon naught 2q upon a square plus x square. This is a simple algebra which I have performed over here, and in the very next step I just want to put the value of cos theta, and obviously in order to put the value of cos theta I have to consider the diagram once again. Now we know cos theta is equal to base upon hypotenuse. Here we are having angle theta over here, and if we look and the front side of the angle, so we are having this OP as a perpendicular and OA will be a base. We always have to find out the angle. Wherever the angle is, in front of the angle we always have a perpendicular, and this will act as a base. So base is OA that is equal to a, and hypotenuse is AP, that is equal to under root of a square plus x square. So we are having a value of cos theta as base upon hypotenuse is equal to a upon under root of a square plus x square. That we will put this value over in this equation, and we will get E equatorial is equal to 1 upon 4 pi epsilon naught 2q upon a square plus x square, and the value of cos theta we have just calculated as a upon under root of a square plus x square. So we have an equation 1 upon 4 pi epsilon naught 2qa upon a square plus x square raised to power 1 multiplied by a square plus x square raised to power 1 by 2. So again, applying a simple mathematical algebra, 1 upon 4 pi epsilon naught 2qa upon a square plus x square whole raised to power 1 plus 1 by 2. When bases are same, here we are having same bases, then powers get added up. So we can add 1 and 1 by 2. Therefore, 1 plus 1 by 2 I have written. So it is equal to 1 upon 4 pi epsilon naught 2aq upon a square plus x square whole raised to power 3 by 2. Now, we discussed it earlier when we talked about the article, that is electric field intensity on an axial line of a dipole, that 2aq is equal to dipole moment P. That is why what I am going to do, I am going to replace 2aq with P. Therefore, we have EE is equal to 1 upon 4 pi epsilon naught P upon a square plus x square whole raised to power 3 by 2. So this is the expression for electric field intensity on the equatorial line of a dipole. So I will mark this equation as equation number 3, but I need to discuss more about this equation. Therefore, I am going to carry forward this equation to the next page. So the equation is electric field intensity on the equatorial line is 1 upon 4 pi epsilon naught P upon a square plus x square whole raised to power 3 by 2. Now we can say that dipole is small. Since dipole is small, therefore a square is very small, and hence it could be ignored. So therefore this equation number 3 will change to E equatorial is equal to 1 upon 4 pi epsilon naught P upon x square plus 0 square. Instead of writing a square, I will put 0 over here whole raised to power 3 by 2. As I said, a square is very small and hence it could be ignored. Therefore, I will consider a square is nearly equivalent to 0. That is why I have substitute 0 instead of writing a square. So we have a very simplified equation, that is E equatorial is equal to 1 upon 4 pi epsilon naught P upon x square whole raised to power 3 by 2, and cancelling the 2 over here, we have 1 upon 4 pi epsilon naught P upon x cube, or I can say E equatorial is equal to 1 upon 4 pi epsilon naught P upon x cube, which is the required expression for the electric field intensity on the equatorial line of a dipole. And this is the final expression. This is equation number 5. If you could recall the previous article, you can easily compare that the value of electric field intensity on the axial line of the dipole was 1 upon 4 pi epsilon naught 2p upon x cube. This implies I can write it as E axial is equal to 2 times 1 upon 4 pi epsilon naught p upon x cube. Now comparing this equation number 6 with equation number 5, you can easily say that we have E axial is equal to 2 times E on the equatorial line. So this is the relation between the electric field intensity on the axial line of the dipole and the equatorial line of the dipole. What I have done over here, I have just replaced this term 1 upon 4 pi epsilon naught p upon x cube with EE, because equation number 5 is representing this equation. I hope you have understood the article, and if you actually understood the article, do not forget to like, subscribe and share my video, and do not forget to press the bell icon. Thank you.